Okay. Now testing. Okay, here we go again. Hi, so today I'm planning on doing three things. First one is continuing from Vim, using Vim, some of the commands, some of the tricks that you can use. The next one I'm gonna be is the Unix in-o redirection, and then also write a small script so that you can use for faster run. I'm gonna demonstrate later, and then the later part of the session is going to be array, solving some of the array problems. Right. Right, so let's 5 minutes. So just here's the link so that you can download the file, and if you want to follow along, just watch this video, pause it sometime if you think it's too fast, and then just follow along. Right, so now we're continuing from the last time is the editing of the text. So sometimes if you wanna insert at the beginning of the line, you can press capital I. So you know that I is inserting at the point of the cursor, but if you press capital I, it will jump all the way back to the beginning of the line. So, and then you can just start typing there. Similarly, if right, so now the task is complete the following function prototype. Right, so for example, if my cursor is here at the end of the line and I want to insert at the beginning of the line, just shift I and then DO, and that will be it. Double. Great. Now if you want to append at the end of the line, similarly, instead of the beginning of the line, you want at the end of the line, you can press capital R A, which is append. Right, complete the following statement. So you see this statement is lacking of the semicolon, so I'm just shift A and then semicolon and done with it. Right, great. Moving on next. Next is if you want to move the cursor to the beginning of the line. Similarly, instead of move it to the beginning of the line and then make it into the insert mode, you can just press 0. This one will go to the beginning of the line but still keep you in the normal mode instead of the insert mode. Similarly, the dollar signs will bring you to the end of the line and so on. So this caret will bring the cursor to the first character of the line. So instead of before that, you just add a character there. Right, just play around with these three commands and see if you're comfortable with it. So this is usually useful when you want to edit things near the end or the beginning of the end of the line. So previously we talked about capital I and capital A is to editing the things that exactly at the beginning of the line or exactly at the end of the line. Instead, this movement, right, it just brings you the cursor to the end of the line, beginning of the line, so that you can do some small movement so you go where you want to edit. Right, fixing typo. Right, you don't want to replace a single character, but you don't want to just press I so you can go into insert mode, press backspace to delete it. Instead, you can just use R stands for replace, and just replace the character with whatever character you want to replace it. For example, right, you see this statement over here, there's some typo. You want to change the character I into character U, just replace it R and U, and similarly for this compute R U. So you see it's fewer keystroke, then just go into insert mode, delete it, input another one. Right, similarly if you want to change the word, you can combine the C character, just press command C together with the word W or capital W for the normal word or the capital word. Right, the difference of word and words already mentioned in the first one, so if you want, just watch it again. For example, for some very long word like this, supercalifragilistic, I cannot pronounce that, but if you want to change this whole super long string here into the hello, you can just C normal W and it's just delete that word and then put you into the insert mode, so you can just type hello. Yep, so useful. Right, another useful editing trick is that you can change whatever inside, you know, the pair of bracket. For example, the parenthesis, curly brackets, double quote, single quote, and a square bracket. All of this, usually they are P in pair and you want to change whatever the content inside it. You can do that by press C and then I and then with one character of the pair. For example, either this character, the parenthesis, or this curly brace. It's all depend on you. For example, yeah, we're gonna go to example down here below. But for example, if you see over here, right, if you put a cursor anywhere in between the pair of bracket like this, and you press change in bracket like CI and then either the left bracket, the opening bracket, or the closing bracket, it will automatically delete everything inside between the pair and then put you in insert mode, so you can here type whatever you inside here. The same go for this, so it's CI and then a double quote, and yep, it's changed it. So yep, you can do whatever, just go play around with it so you're comfortable with it. Please note that CI opening or closing bracket, they have the same effect, and this is applied to curly braces and square bracket as well. The most common case I think that you're going to use the most is, for example, changing whatever the content inside this double quote here, like printf, scanf, whatever. You want to change that quickly, just press change in and then double quotes. It will put you in there and it just change accordingly. For example, like that, quite fast. If you go the normal way, maybe you have to like go all the way there, press insert and then delete. It may take some time. Right now you change the parameter in the follow function prototype from in float. Right, one way of doing this is for example, if you see over here, right, if you do the normal way, maybe you insert here, backspace everything, then type out float for example. But there's another way to faster doing that, is to change in and then either opening or closing bracket, it doesn't matter. So just do like so and then float. So if you notice, right, I type the float 3 times, you may make it faster. For example, you press 3I and then F. Let me do it. So maybe you may want to try 3 insert and then float, then press enter, then it will go float all the way. So let's try that. Yeah, it's come out something like that, but that's not the point here. It's just changing this one and just flow and flow. All right. Sometimes you find yourself doing the same editing sequence repeatedly, so this is a hint that you can use a full stop. So whenever you do a sequence of editing, right, it will save in the buffer, and when you press the full stop, you just reapply the sequence again to whatever the position of the cursor is on. For example, instead of just changing one function prototype like above, you want to change 3 of them exactly the same way. So instead of just CI and then open or closing bracket and then type in the float and then repeat for the same things over there, it may take some time. So what you want to do is you go move the cursor to the first, anywhere between the pair of bracket over here, to change it into float, float, float. Right, press escape, so that is escape there. Just put a cursor on the in between the bracket and then press full stop. It will automatically reapply the sequence, the editing sequence that you entered just now. And here you go. Quite quick if you want to do mass editing. Right, now go with function definition. Okay, so the full stop is quite powerful if you know how to use it. So for example, now let's say I already defined the function prototype above and I want to redeclare it over here, under here. So the first thing I want to do is I want to delete this semicolon. I want to put a square bracket, the curly bracket, and close it. Right, and I want to do the same thing for these two over here. Instead of I redo the things, I just press full stop and it reapply for me. Alright, hang on. So I press capital A, so it's bring me all the way to the end of the line. Press backspace to delete that. Open. Okay, over here, reapply it by just pressing the full stop. Pressing full stop, pressing full stop. Yeah, so it's quite fast if you want to do that, a lot of things. And the next thing I want to talk about is searching. Searching in Vim, they use regular expression, so if you are familiar with that, great, you can apply it. But most of the case, just searching for exact words. So to search for any words, you press the slash and then start typing. You see that the splash is on the left, the lower left corner, and just type in whatever word you want to search for. And in this case, I want to search for hidden, the word hidden. And once I'm done typing the word, just press enter. And to move to the next result, right, you see the highlight of the cursor where it is, so it's searched and it's fine there. You want, because I use the splash, so I'm searching forward. Searching forward means that from wherever the cursor is, it's going to search downward to the file, and the moment it's reached the end of the file, just go back to the top. So just go from top to bottom. If I use a question mark instead of the splash, it's gonna do the reverse. It means it's go from bottom to top. And if you want to go in the same direction of the search, you press the normal N. That will bring you the next word, for example, like that. Or if you want to go the opposite direction, you can use a capital N, like so. Right. But sometimes you want to search for a word that directly under the cursor. For example, if I want to search for the word Google, I don't want to splash and type the Google all over again. What I want to do is I just want to press the star. It's going to bring me to the next word of the Google on the same line. And similarly, if you want to go backward, you can press the hash. Yeah, like so. Right, how about searching for a character you want to search forward or backward? Well, you can use the normal F to search forward. Search forward, so that means search from left to right, from the cursor to the right, and capital F is going to search from the cursor to the left. Right. So, for example, if you want to search the first occurrence of the R on this line, just press F and then R. It's going to find the R. And if I want to go continuing going in that same direction to the next R, I'm gonna press the semicolon. Semicolon again will bring that. If you want to go opposite direction, it's just colon, comma, like so, right? And this is only applying for one line, right? The more important things I think is searching for matching bracket to check if you have an extra bracket or shortage of brackets. You can do that by pressing the percentage sign. So what you want to do is you move the cursor to the bracket and then press the capital, press the percentage sign, and it will search for it. For example, in this case, you see that is the cursor is going for the opening parenthesis, and then if you press the percentage sign, it's gonna bring you to the closing of it, because it's a matching. Similar for this, I press percentage sign, but it doesn't work. Why? Because there's some function, some bugs over here. So in sometimes you see that there is unmatching of this, and you don't know why. So you bring the cursor to that and press the percentage sign. It will bring you to the matching one. In this case, bring it all the way up. So this means something is wrong. So let's check from this first. Right, so this one is matching, which is good. This one is matching, is good. This one is supposed to cover the whole if, but in this case just cover like that. So that means I'm missing 1 by 6. So now I put a cursor here and press the percentage sign. It's matching, that is, and everything is great. Now let's check for this one. Okay, so this one is matching for the if one. That means that things over here doesn't match. So I'm missing 1 closing bracket here, and my code should work again. Right. Now the last thing I want to talk about is the search and substitute. So it's quite rare to use, but sometimes if you want to change the variable and you want to change it in many places, and you don't know where they are because you just use them all over the place. For example, right, you can use a global substitute by using a vim command. To open the vim command, right, you press colon first, and then you start typing. You see on the bottom there is a colon, and then the cursor is there. So if you want to change all the occurrence of things, right, you can press percentage s. Percentage will indicate every line of this file will be affected. So now splash. Now the first thing you want to put is the word. Alright, welcome back. So hopefully still there. Okay, so I'm experiencing some of the frame drops due to the poor network connection. I'm not sure why, but the US connection is start to act up, so please bear with me. So next things I want to talk about is the IO redirection Unix. So you know that sometimes you have a test case that have a lot of input. So if you manually input that, it's gonna take a lot of your time. So what you want to do is you want to use the less than sign and direct the input in there, and the greater than sign to output into another file instead of just a console. So today what I'm going to show you is I write a little script that will take in the file, compile it, and run it against some of the test cases automatically, given that if you have the following file structure. Alright, so I'm going to put up the link on the command section so that you can download it. So it's a shell script, so hopefully it can be used on Sunfire server. So here is my folder direction. So over here, hang on, let me remove it. So over here I just have my file election.c. Then I have 3 folders. The first one is the input, which is the given input folder. You see the naming is whatever the file.c is, plus a number, and then plus .in. Similarly for output as well. So the input, whatever inside the input is the test cases that you are going to test against, and the output is the expected result, right? So what I did is that I create another answer folder. In this case, answer, where will store all my answers that is produced by my program. Right, so with all this set up, what you need to do is just run the script, and you input. The first one is the name of it. For example, election.c, just input the election, and press enter. It will automatically run against all the 10 test cases inside. So yeah, if you don't see anything, is good, because I use the diff function over here. So if you see over here, what my script basically does is, first of all, is look for the folder. If it doesn't have the answer folder, just create one for you. It's going to compile your program over here, and then just run against 10 test cases. So for all of the test cases, it's just going to take the input you see the IO redirection here. You just take the input from the input folder, and it's gonna produce the output inside the answer folder, and it will have the .ans here. And then what it does next is diff to see the difference between this is the answers my program produced, and this one is the expected output on it, and it just run against that. If there is any difference that you can see is display over here. So that's about it. Later I'm gonna use this to test some of the program. Right. Okay. So I'm just gonna, So the first problem I'm gonna solve today is the river rabbit jumps. This one is in the practice one, so it's rabbit jumps over here. You can download it. Right, reading, this is past year CS. I don't know what past year refer to, but yeah, it's a PE exam question, and it's expect you to spend 1 hour. So let's read the question. Paste the question 1 on the comment section. Right, let's read. A rabbit cannot cross the other side of the river, but it cannot swim, so it have to hop, and each hop can bring it at most 50 centimeters away, and its only hope is to jump on the rocks over here to go to the other side. Sorry, excuse me. Right, so for example, in this case, the rock stay at position 32, 46. All of this position is in relative to the beginning, the starting point. Right, all of this, and this one is the furthest one. Right, all of these numbers going to be given inside an array. So you jump as far as you can, as a small. So the question asking is, given this position array, how many hop that the rabbit is gonna take so that it can reach the other side, and you have to find the smallest number of jumps. Right. So you may assume that there's at most 20 rocks. So the more I read this, I know that the array size is at most 20. Write a program rabbit.c that read positive integer n. So you're gonna read a number n that represent the number of rocks, and then the next line is n distinct positive integer in ascending order, so that represent the position of the rock. And the program is expected to output a minimum number of jumps, or -1 if it's impossible. So you see the limitation of the rabbit is can only jump 50 centimeters away. So if it's more than that, then probably it cannot, and you will output -1. So the expected is your program should include a function count jumps, and it's expect an array, and this one I suspect to be the size, right, the number of jumps. So here's some of the sample input and output. Right, what I'm gonna do, let's go into analyze the question. So delete this. So this one is practice S04B03, and right, so here is a skeleton output of it. Okay, before we go into any further, I'm just gonna analyze it. Let me do it on this one side. Okay. So here is I have skeleton on the right hand side, and then the question is on the left hand side. Rabbit can jump as more 20 centimeters. It's gonna cross the river. Alright. So how do we solve it? So you say the smaller numbers of jumps. So intuitively, let me write down the requirements. So given the position array of the rocks, this one is relative to the starting point, and you have to find the smallest number of jumps to reach the other side. Right, so inside this position array, the last element of it will be the other side of the river. So one way of solving is you see we're asking for the smallest number of jumps. This means the rabbits have to jump as furthest as possible from wherever it is to reach the riverbank as fast as possible, so as fewer jumps as possible. Intuitively you think that maybe an answer, but you're not so sure. Now I have a thing of a proof. For example, let's say that here's the rabbit, and let's say this bank, and here's a rock. Like for example, let me denote this one as a rock, and this one is at the end of the bank, so I'm just gonna put here, for example, like this. So let's say in an optimal, optimal solution, that means this one is the best solution that the rabbit can go. Like it make the fewest jump for this particular example. For example, all of these stars, right, is the optimal jumps, like so, right? And what our algorithm do is algorithm is gonna choose the furthest, always it's gonna be always choose the furthest rock that it can jump and take the jump. So the question here is this optimal? Is this the correct solution? So the answer there is in this, actually is yes. How to make it clear? So that, alright, over here let's say that is take 1, 2 and 3 jump, and this is the optimal solution. And let's say our greedy algorithm, the given it is a g. For example, here is the g that we take, because g is always the furthest that it can jump, right? Let's suppose that there is inside the optimal solution, and there is a rock that the rabbit can jump, but it's not the furthest from wherever it is. Let's say here's a star over here, right? So to go to the next star, right, is have to go through this distance, and our algorithm choose the furthest rock it can go, and let's say is jump to g, right? So g can also reach this stars because the distance between g and this stars is less than the distance of this star to this stars. So if the rabbit can jump from this star to this star, that's also mean that the rabbit can jump from g to this stars. Does mean that our greedy algorithm will ensure that the rabbit can reach the optimal solution. And if you think about it further, is that the rabbit will eventually reach a solution that is either better than the optimal or is the best already. If it's too confusing, you just think of it this way. To take the smallest jump, the rabbit just jump as further possible as possible, and that's the greedy choice. So now to the procedure code. Algorithm first. So the above is a summary of algorithm. It's quite simple, but we can break it down a little bit more further. For example, take. So what the algorithm does is while the current position of the rabbit is not the other side, take the jump to the furthest rock. So the furthest rock is what? It is the greatest difference between the rock that you jump minus the current position. If it is less than or equal to 50 centimeters, then the rabbit can jump to that rock. So that is the furthest one. So you just take the maximum difference between the next rock is going to jump in the current position of the rabbit. So jump to the rock which have the greatest distance difference between that rock and the current position. And this one is given a condition that the distance is less than or equal to 50, because if it's further than that, then it's not possible for the rabbit to jump there. And if you find yourself in a situation where the distance is greater than 50, that means it's impossible for the next jump, then that will be a -1 for your input. So if so it's have to have at least one such rock, otherwise it's gonna be -1, impossible for the rabbit to jump. So here is while the current rabbit takes jump to the first rock. If there is no such rock, return -1. And this one will guarantee you to jump over there, to jump all the way to the other side, and otherwise you just increase the count jump, because this one you keep jumping, so every time you just increase the count jump, and then yeah. So this one just if, otherwise just increase the count jump and go through the loop again. Repeat until you the rabbit reaches the other side. Okay, so now the algorithm seems to be okay, it's understandable, but how do you translate this into pseudocode, or even better yet, into C program? So let's write it into pseudocode. And in this problem, there is 2 tasks for you. The first one is to count the number of jumps. This one is minimal, but the next one is to determine what is the furthest rock it can jump. And this one